All right, welcome to the evening session of the first day of NDC. So my name is Nick Randolph. I run a consulting company called Build to Roam, and
Hi, my name is Pooja Bhaumik. I'm currently coming from India, and I am a Google developer expert for Flutter from India. Yes.
All right, so today hopefully you'll get a bit of a taste for what Flutter is all about, and what we're going to hopefully do by the end of the session is also talk through how useful the Azure components, or what's there in the mobile space in Azure, and how you can connect your Flutter app to them. So we'll go ahead and get started. So what we're going to do is, just before we sort of delve into Flutter and Dart, we're going to give you a little bit of background of, I guess, as to how we came to use Flutter. So this isn't technically correct. There's a mistake on this slide. So let me see. Is our slide's going to behave? Yes, there we go. Awesome. So this is all about how I met your Flutter. Okay. And so my experience is somewhat different from Pooja's. So I run, as I mentioned, I run a consulting company, and we predominantly do cross-platform apps. And so we do apps that target one or more devices. You can imagine that most of the apps we do is iOS and Android, but actually we do a lot of Windows stuff as well. So we do Windows Desktop, Windows, Xbox, etc. And so I guess my background is in the Microsoft ecosystem. So of course we use Xamarin. And so, a lot of the apps that we work in is Xamarin Forms. But one of the things that we found, over the last 2 years is that the design philosophy associated with building mobile apps has changed. It used to be very much a, hey, I want the native platform controls for my app. Whereas these days, the branding from, the branding department, most companies, whips us into shape and basically said, no, we don't care about the platform idiosyncrasies. We actually wanted to look on brand, and we wanted to look perfect, and we wanted to look pixel perfect with great animations. And so all of a sudden, us Xamarin Forms developers are going, that's a bit of work. I'm not sure I like building renderers. When Google came to market with Flutter, it was an opportunity to take a look at that and understand the differences there. Because from a Xamarin Forms perspective, we kind of looked at some of the other cross-platform technologies, and those didn't really give us a better offering. So for us, Flutter gave us an offering, and we'll talk a little bit in more detail exactly why that's the case. So anyway, that was my background, so I'll hand over to Pooja.
Yeah, so my addition is a little bit different and longer, I guess. So how many of you are actually native Android developers, if any? Great, awesome. So I've also been working with Android for more than 3 years, and I thought that I was in love with Android. But then I think I started an affair with Flutter. So it kind of went like, it was like Android and I still were in love, but Flutter and I had that connection that was a little different. So what went wrong with me and Android? So it was a 3 years relationship if you count that chasing period where we were trying to get to know each other. But after a certain point, it kind of became a little too comfortable, and that spark was gone. So it came to a point where I had that phase in my life where I wanted to try out other frameworks. So I thought to myself, really, this like one thing, do I do this one thing my entire life? So I wanted to try out other mobile frameworks like React Native, Ionic. I even tried out web because everyone was talking about it, and it was a big jump for a mobile developer because I was not just cheating on Android with other mobile frameworks. I was considering other platforms. So, but then it never worked out because I just could not understand them. Like all of them had the same upbringing. So, yeah. So it's like the soul, the personality was so much similar. I realized I think I like Java better. So I joined this company last year as an Android developer, and the boss tells me, so here, this is Flutter. It's new to town, so hang out with it. So I started hanging out with Flutter, and one thing led to another, and I stopped talking to Android. So Flutter made me realize that how it's like to be a mobile developer again, and it was exciting, it was fun, it was like me again. So what is Flutter, by the way? However I narrated that story, it is kind of true. So Flutter is a cross-platform mobile development SDK that lets you build Android and iOS and now web and desktop apps through one code base written in Dart. Now Dart was completely new to me because probably nobody had heard of Dart before Flutter as such, but it was a relief that it was not a JS framework. It was much more easier to learn, and it had this interesting widget concepts. So where widgets are basically like blocks or components that build the user interface. So in our case, the app bar would be a widget. The text on it is a widget. The style that you apply to that text would also be a widget. The padding around is a widget. The space is a widget. So it had a very interesting concept of widgets where you could build amazing custom UIs with just widgets. So Nick, I guess you were building some application on Flutter, so why don't you tell them about it?
Yeah, so I'm going to just jump into VS Code just quickly and show you a vanilla brand new app. And so rather than trying to demonstrate building an entire app, I'm going to show you the very basics of getting started with VS Code. Just a side note, if you don't like VS Code, you can also use Android Studio. So if you're more familiar with sort of the Android working sort of workflow, all of the tooling is there in Android Studio as well. Coming obviously from a Microsoft-centric background, I tend to gravitate towards VS Code. So let me see if I can grab a new project. So the really nice thing about what Google have produced is they've done the integration really well into VS Code to the point where I can go ahead and create a new project. I can go NDC demo and give it a folder, and off we go. And so one of the things you'll find is it's not just the code editor, they've also integrated a number of the tooling windows. There are some that still sit outside of VS Code, so there's what they call the Dart Dev Tools, and so there's components there that sort of, if you want to get into the world of sort of performance tuning of your app and looking at the actual runtime behavior of the app, then you'll actually end up using those tools. If you're using Android Studio, a few more of those windows are actually baked into the actual IDE itself. Sorry, I'm kind of feeling while Flutter Create does its thing. So you can see on the bottom right-hand corner, the pop-up there is basically saying, okay, it's running Flutter Create. So if you don't like running using the IDE, you can actually drop down to the CLI and just run Flutter. Basically, the IDE is really just a sort of nice editor around the command line interface for that. And that goes for building and packaging, et cetera, as well. So whilst it's doing that, over on the left-hand side, you can see that it's starting to fill out the various folders that are going to make up our application. And like with most other cross-platform technologies, you'll see that there are head or target folders for iOS and Android. And actually, I'm running the master channel, so you can actually see that there's a head project for web as well. If you just go and grab the stable release, you won't see that right now. So 1.9 doesn't have that baked in, but the master channel, so the one that they're committing to at the moment, does have the web. And so, but the main part of my application is going to be this main.dart. And so, like with all good applications, it starts with a main routine, and that's where it's essentially going to launch our application. So at this point here, where we're looking here, we're really just talking about a Dart application. Okay, so what's this thing called Dart? Well, as Pooja mentioned, it's a new programming language. Well, it's actually not that new. It's been sort of gravitating around in the sort of the Google space for almost about 6 years or something like that. And actually, Flutter's been around probably about that length of time as well, because it was an internal Google project used for a number of their apps before it got released out to the public as well. But a Dart application starts with the main routine, kind of similar to other programming languages. And in this case, we're going to call run app. Now, run app's basically provided by the Flutter SDK. And for the most part, you don't need to worry too much about that, other than the fact that it takes one parameter, and that parameter is, can anybody guess what it is? It's a widget, exactly. And so here we are actually launching our application. I'm going to press F5 because it will take a minute or two to spin up in the emulator. But I'll talk through this while it's doing it. So right here we've got my application, or my app, and it is or it extends stateless widget. Okay, so we've got sort of typical OO paradigm type stuff happening here where we're extending a base class. In this case, it's a stateless widget. There is also a thing called a stateful widget. So as you're managing the state of your application, you are going to need to think about whether you're using a stateful or stateless widget. But that's like a 2-day course in itself. No, it's not. It's about a half-a-day course, but it's definitely something that you need to spend a little bit of time with. So as we delve down into here, probably the next most important thing is this build method. Now, one of the things that separates the way Flutter works from virtually every other sort of technology or sort of cross-platform technology is the fact that of the way that it actually does the rendering to the screen. Now, this came out of the work that Google did around Chrome. And rather than defining the elements on the screen and then updating them, which most other platforms or frameworks do, so in Xamarin you define your stuff in XAML, generates the screen layout, and then if you want to update things, you either use data binding or you're manually updating properties on those elements. In the Flutter world, we generate our widget hierarchy, we hand it over, and then the build method gets called again, and we generate a brand new set of widgets. Okay, and you're thinking, ooh, that sounds very heavy. But no, actually what happened is behind the scenes, it does a differential. So it kind of works out what's changed and only updates those parts of the screen. Right? So the widgets themselves are designed to be extremely lightweight. They're designed to be generated and disposed of very quickly. Okay, so the way that this build method calls is basically every time I want to make a change to the page. So for example, in this case, it's a counter app. So we're going to hit a button and we're going to increment the counter. Every time that runs, or every time I hit that button, it's going to trigger a rebuild of my widget hierarchy. But the only thing that's changing on the screen is going to be the actual count itself. So that's the only thing that's actually going to get repainted. As a developer, you don't need to worry about all of that. All you need to know is you need to rebuild the widget hierarchy and hand it off. Okay. So let's actually see that in action. Let me see if I can minimize this down a little bit, move it across. And where did our emulator go? Okay, so here's our emulator, and there we go, we're incrementing it. And the nice thing you'll notice here is that immediately we've got the sort of the material look and feel. We've got the fab down the bottom right-hand corner, which is our sort of our singular action button, and then we've got things like the app bar at the top. Everything you see on the screen is itself a little widget. And so, as you're starting to build out the layout of your screen, you'll actually think, okay, well, what widget do I need for this? And you'll go off to the widget hierarchy or the widget index, and you'll find the appropriate thing. So as you can imagine, we've got bits of text on the screen. So what's the widget going to be? It's going to be a text. There's a floating action button. It's called a fab. So there's going to be a floating action button widget. And so app bar, it's called an app bar widget, right? So they've done some really good, sensible things with the naming things. So quite often when you think, okay, well, I need a card to display on the screen. Okay, you go Google, Flutter, card. Oh, look, there's a card widget. And so it's very easy to build up the hierarchy because of that. Now, let me just quickly set a breakpoint in here, just in case you didn't believe me that the rebuild gets called every time. So I'll put a breakpoint just in here. And we'll go ahead and click on there. And so you'll notice here that, first of all, we've got breakpoints that we can step into. We've got some really nice stuff over here about call stacks. So all the things that you'd expect in a modern IDE are all there. Okay, enough about this counter app. What we're going to do is actually go ahead and actually have a look at a more realistic app. And one of the things I always struggle with is keeping a track of the list of things I'm going to do. Okay, so I'm going to go ahead and actually switch over, and we're going to have a look at a basic to-do list that's got essentially a couple of things on the screen. So again, you can see this workflow of making changes on the screen and actually updating the screen through this build method. So let me just minimize that. We'll go across to, let me see, this one. And let me just stop that. So this is our simple to-do app. And we'll go from the top. And so one of the things that you'll notice here is that, again, we've switched away from a stateless widget to a stateful widget because we're now going to be tracking some state. Okay, if I wasn't going to track any state, so I didn't have a list of tasks, I could get away with it being a stateless widget. Okay, we are going to track my list of tasks, so I want to make sure that it is a stateful widget. And what that means is I've got to have a state object that goes with it. And so you'll see quite a common pattern in Flutter where you've got your actual widget associated with a corresponding state. So you can see here, this is my homepage widget. and the corresponding state. So if you think about life cycle of things, the state is something that's going to persist around, whereas your actual widget's going to get regenerated every time something on the screen changes. Okay, on the right-hand side, you can see the emulator running, and essentially, if I click into this top thing, which is a text field, I can say pick up the milk and press enter, and it's going to go into my task list. Okay, so what's going on there? So if we take a look at the structure of this, so here we've got a thing called a scaffold. Okay, so within our material app, we've got a scaffold. The scaffold's useful as a base because it gives us things like the app bar. Okay, so at the top there, you can see that we've defined an app bar with a title in it, and we've got the body. And then if we wanted to do things like a bottom tab bar and a fab and things like that, those things are all built into the scaffold. Okay, the next thing we're going to look at is the body. And because we're going to be essentially, we've got two items there, we've got a text field and we've got a list of items that are going to appear underneath it. Those are laid vertically in a sort of a column-like structure. Now, we just did a 2-day workshop and it was surprising how long it took people to grasp, okay, this is a column because things are stacked on top of each other, or this is a row because things are stacked across each other. Okay, it sounds a very basic concept, but if you start to think about the user experience of your page and you start to put lines through the various elements and work out whether things are stacking vertically or stacking horizontally or a mix of both, you can quite easily break them into rows and columns. Now, if you're coming from other technologies where you're used to like a grid that's got rows and columns inside it, don't confuse them because they are actually different. These are actually closer to a stack panel or a stack layout, depending on what technology you come from. Okay, so within the column, we've obviously got a children property. And so we've got two elements that make this up called a text field. And at the bottom, we've actually got a nested structure because instead of just putting our list in there or a list view in there, we're also nesting it in a thing called expand. And basically this says, hey, expand whatever the child element is to take up the available space. So this came back to Pooja's point that everything is a widget. So you want to put padding around something, there's a padding widget. You want to do, control the layout of something, there's going to be a widget for it. So for example, centering something, there's a center widget. You'll end up with this hierarchy of elements that allow you to define where things are going to be. Okay, so let me put a breakpoint in our text field just in here, and we'll go and add another item in here. Obviously one of my to-dos. Okay, so you can see that it's come in here, and we're going to add this task to the task list, and I can sort of F10 and step through that, he says. Okay, so we can go ahead and create that. It's very, very sort of OO paradigm. One of the interesting things here is that you've got this dot notation. Essentially, that's a cascader, so you can actually set multiple items if we wanted to on there. One of the important things that we need to do at the end of this method, so we've added an item to the list. At some point, we need to trigger that build method. Remember I said that in order to update things on the screen, we need to rebuild things? Well, if I was just adding stuff to the list, the framework's got no idea that I've added stuff to that list. It needs to be told. And that's where this set state comes in. So if I let this run to enter this breakpoint, at this point, the screen hasn't updated at that point. Even though we've added it to the task list, it hasn't updated. If I let this run now, it's going to add it to the bottom, and then it'll actually call that build method again. Okay, so set state is that trigger to say, hey, the state of my object's changed, call build, and then off we go. And there we have it. We have my beautiful looking task list. And like, I don't know, I reckon I've done a pretty good job.
Did you just call it beautiful?
Okay.
I mean, seriously?
Okay, what are you going to do about it? Come on.
Yeah, I mean, Flutter is there for making beautiful applications, and you call that beautiful? Maybe let's see how we can make this beautiful. So let's see if mostly we have a to-do list, so we can have cards that we were talking about. So let's just add something like a card widget, and so, yeah, I guess you can see something like that. But what I don't like is that I hate this white theme. Can I make this a dog theme app? So here, maybe I'll just add a dog theme. Yeah. And I'll enable the dog theme mode. theme. Sorry. Yeah. And as you see, this will automatically update the UI just in 1 second. So now you have a dog theme mode app, and maybe I'll do something regarding the card where I need to add some padding because I really can't see anything here. So I can add something like add padding. So that's it. I just do not have to do anything, and now I have a padding around the text. So this looks fine. Now can we do something regarding the text fields where probably we can add like a prefix icon. Yeah, I need to add a decoration. So I need a decoration, so here I can do a box decoration, and maybe, sorry, so maybe we do a prefix icon. So, so yeah, this is why I don't do live coding, but yeah. Okay, will this work or will this not? There is an error. Yeah. So we have added some really random icon right there. So I can like, so Flutter has a material library of icons and colors, and you can just get the icons right here. So if I want to make this something else, it will already be here. So maybe I do something like, what do I do? So like a business, because it's a business task maybe. So I added it right here, and then I can, what else can I do? Probably I can create a special list view here. So suppose if I can reorder the list view right now, so something like reorderable list view. So that's also right there. So instead of all this, I will probably have something called a children, which will take a list generate, and it will take task.length, and hopefully everything in here can be added. So maybe I'll add it here. So yeah. So we have a reorder which says that we need something else, which is like what happens on reorder. So I have to add another param here, which is on reorder, which would say that when the index is changed, what do I do? So here I can just do update items, and that's all. So now if I run this, hopefully I can reorder my list view. Did it work? Oh, it did not work. So yeah, I guess there is something wrong here. So yeah, this is exactly why I don't attempt a live coding. This would be my last live coding right here.
Okay.
But yeah, so this is how you could like actually reorder or make your UI better. And as you see, that hot reloading is really working super fast here, and I can just like change my UI changes quickly right now. If you're coming from native Android, you would know how much it takes in Gradle building. It actually takes around like 5 minutes to actually just update a change, but this was like really quick. So, but there is a problem here that we cannot actually save our data here. If I rerun this app, this will actually go back to 0 task. And honestly, I'm just a mobile developer. I cannot do anything regarding backend services, and I want my app to be used in different devices and have all the data and tasks reloaded as soon as I open my app. But I have no knowledge in backend services.
So I'm pretty certain I can help you with that.
Can you? Okay.
Yeah. So I reckon we can probably connect this to a few things in Azure to make your life a little bit easier. So let me just switch back to these and see if our slides are going to magically change. Okay, so Azure for mobile apps now. In the world of Azure, as you all are probably blindly aware, has continued to evolve. So this isn't a definitive list by any stretch of the imagination. It's probably a thing that's changing on a sort of semi-daily basis. But I guess there's a few important concepts coming from the mobile world that it's worth noting. The first one is around DevOps. Now, it's quite interesting when I talk to developers, and if you're working in the web space or APIs, there's a mentality in most firms now that okay, they've got to get their DevOps organized. They've got to have a build pipeline. They've got to have a release process. Even if it's a manual release process and we have an automated build, etc. At least I know when I'm breaking the build and everyone's broken. So at least you've got the blame there. But in the mobile space, it seems like people haven't really cottoned onto that, or it's only just starting to emerge now. And I think part of the fault there is on the tool vendors, because if you're building using, say, the Microsoft toolchain, then actually in order to do a build, you actually need to install the toolchain on a machine in order to do the build. And so most of the online services for doing automated builds don't have that. And so the same with the Flutter world. I mean, if you're going to do a Flutter build in the cloud, you actually need the Flutter SDK installed. Now, the good thing is that those hurdles are being eroded. Most of the big vendors now actually have a lot of those SDKs pre-installed on some of their build frames. So it's becoming a lot easier. So build and distribute, highly recommend getting it set up straight away. We're not actually going to go through that process today, but I will show you a build that we do have set up for this particular application, and you can see that we can actually set it up in Azure DevOps. There's some third-party providers like CodeMagic and stuff like that that also have those sort of CI/CD pipelines set up. The other sort of aspect that falls loosely into DevOps is the notion of crash reporting and analytics. And so as part of this, we'll also show you the Visual Studio App Center. And one of the sort of the areas that Microsoft's working on in that space is the ability to report crashes. And it's actually relatively easy. Somebody actually generated a plugin for Flutter to allow us to connect into that. And that gives us sort of crash reporting and analytics and stuff like that. Obviously, security is a big issue for mobile apps. You want to make sure all your data is secure. I tend not to work on apps where they say, okay, the first screen we want to create is a username and password screen where we're going to be plugging it straight into the app. And I'm thinking, yeah, okay, so where are you storing those credentials on the back end? And they go, oh, well, we've got this encrypted database field that we've got the hash to that we can unencrypt, and all of a sudden I'm going, yeah, no. So making sure that you pick a good identity provider or multiple ones of those. I'll show you how to connect or how we can leverage some of the power of Azure around the app service and actually connecting through to things like Azure B2C or Azure Active Directory, or connecting it through to other third parties is fairly easy. And again, there's plugins available for Flutter that people have worked on to allow you to do that sort of OAuth workflow to allow you to sign in. And that kind of goes part and parcel with authorization. I'll show you then how you can connect the sign-in process to the security on your services. That's mainly all back-end stuff, but obviously there's you need to make changes to your app to actually walk through that process. So you actually need to call out and make sure that they're authenticated, check you've got a valid token before you sort of progress to the next stage. And then, of course, we actually need to be able to call our services. Now, in this example, I'm using an app service, but you can apply the same thing to a function, okay? And rather than manually coding it, so http.get or things like that, we're actually going to show you how you can actually use the Swagger to actually generate code that you can then embed it within your app. So it saves you a whole bunch of typing. Okay, I mentioned Azure DevOps. Okay, so this is the plugin that one studious developer has built. And actually there's 2 or 3 of them available now. One which does just a vanilla install of the Flutter SDK. So if you want to go and write your own sort of build chain, etc., you can do that just by incorporating the install of the Flutter SDK into build process. And then there's a more fully fledged one that actually allows you to build and release as part of the pipeline. Visual Studio App Center. How many people have heard of Visual Studio App Center? Okay. If you're in the mobile space, it is worth looking at. When I initially put these slides together a while ago, that these are the main things that they were doing. They've actually worked into the sort of the data platform side of things now. So if you're looking at doing and authentication, so if you need somewhere to upskill an app without having to pay the world in Azure, then you can actually go to Visual Studio App Center, and it gives you those building blocks that you can quite easily get started with. And so identity and data sort of back end are coming to App Center as well. So, okay, I mentioned Azure B2C. This is just one of the many identity providers that are available out there. It's one of the bigger ones. Obviously, it's backed by Microsoft. The other one we quite often use is Auth0. That's sort of like one of the main ones, sort of in that sort of customized workflow space. But obviously, if you're working in the sort of the social space, then using sign in with Facebook and Apple ID and things like that are all part and parcel of it. They all kind of work the same way. They'll all work, open up some sort of web view, get the user to sign in and pass back a token, so that your app's never actually responsible for username and password information. And obviously, the user has to grant your application permission. So the nice thing about Azure B2C and what Auth0 do is that they actually provide you with they can allow you to use multiple providers. Okay, so it's essentially plug and play. You can basically say, okay, well, I want to enable Facebook and I want to enable Google, and so it gives you that one staging point, and then rather than being wholly reliant on Facebook's sort of set of credentials, they then provide you a database where you can essentially have some user information that sits off there. So you can actually capture, as part of that initial sign-up workflow, you can actually capture, user like first name, last name. You can capture address, or you can customize it to add in your own fields. You can also define policies, so you can basically say, okay, well, the user has to sign in every 30 days, or re-authenticate within a certain period. And the nice thing about Azure BDC, of course, it links very well into App Center, into your regular app services, so that you can use it for authorization. So when you go, we'll see it today, when we go across to the portal, we'll actually go into App Service and actually customize the authentication or the authorization within there. Okay, and last, of course, is our app service. And for this particular one, we're obviously going to track our tasks. And so I could have actually probably got away with using a function for this, but for convenience, I went with it's a .NET Core app service that sits in the background there. Okay, so let's connect the dots and see how this looks. So let me switch out. I'll minimize this one. That's our demo, which I can now close. And this is simple to do. All right. Okay. So this is essentially the same demo that we were walking through earlier, but now we're actually going to connect it to various parts in Azure. So before we do that, let me actually switch over to the various pieces of Azure we're going to be talking about. So the first one is Azure DevOps. So I mentioned the sort of the build process. This sample was really cool. Originally called the world's best Flutter app because I couldn't think of a good title for it to do app. Anyway, so in here we've got things like we've got a series of builds, and I can go in and actually go and edit that, and you'll basically be able to see the various stages within those. And so essentially we can manage our whole build pipeline. One of the challenges with mobile app dev is actually less around the build process, but more around the release process. So in most other sort of technologies, if we're working in the web space, most of the time as part of our release, it's a matter of, okay, well, we've just got different configuration for our existing assets. So, the artifacts from our build process, we go and change the configuration for our various environments. It's actually a little harder with mobile apps in the sense that there is no configuration that gets packaged with an APK or with an IPA. So you can't actually go ahead and just reconfigure it like that. There are some third-party tools that allow you to essentially pull it apart, replace a file and then re-sign the application. But that is one of the challenges of that sort of build and release process. It's also one that I might add is actually not generally solved. And quite often most people will end up just doing another build as part of that release cycle. So yeah. Okay, so that's build and release using Azure DevOps. Just to show you that we are actually connecting to a real service, this is our simple to-do service that's going to return us a list of tasks. Those are JSON tasks. We'll come back to that one in 2 seconds because I want to show you how we can take that and actually generate the client-side code that we can then use within our application. And then the other one I wanted to show you was application insights not application insights, the App Center. So this is the App Center for our world's best Flutter app. And when you land on the overview page, it gives you basically getting started guide. Now, there is no Flutter option when you go through setting up an app in App Center, but if you pick the standard iOS or the standard Android app, it gives you the necessary information, which actually is buried here. It's basically the key that you need to get started. So then you go off to the Flutter list of packages, you grab the App Center one, and then you go to your app and you plug in that bit of code there. Now, here what you'll see is that we're actually doing a check based on what platform type we're targeting, and obviously I haven't put the iOS one in here, but essentially we're picking up the appropriate App Center ID there because they do at the moment they differentiate between your Android and iOS app. It is a little bit painful because they're treated as 2 independent apps, and they haven't got to the point where they've got a unified view of that right now. So it does mean you need to differentiate that in your code. One of the nice things I would add though is if you actually pull this bit of code out and put it into a constants file, Flutter, when it does the build process, is actually smart enough to realize that it's building for iOS and Android, and it will actually cull out the bits that it doesn't need, so long as you factor it correctly. Okay, so the next thing, I'll just scroll down to here where we're actually using our App Center key. So here, this is where we're actually calling appcenter.start, so it's essentially a static, and we're doing that as part of the initialization of our app. And then finally, when we go down here a little bit further to the code that we were looking at earlier, where we were adding a task, this is where we're going to actually track that event and publish it back up to App Center. So if I go back up to App Center, I can come over here and go to Analytics. And what you can see here is that, and this is a really low utilization app, but you can see that as people add tasks, you can see that the events actually appear in this event list. And it also is quite useful. Let me see if I can break this down. No, it's not going to let me because the data's a little bit old now. Oh no, here we go, events. And so down here, this adding item is actually the same bit of text that we actually had here, along with the item that was added. So in this case, I was adding, let's see, what did I add? Okay, test 1 and test 26, they weren't really inventive ideas, but the point is that you can actually provide back up here information about the usage of your application. Just be careful of privacy requirements here when you're tracking stuff. Obviously, don't put any sensitive data into your analytics information. So I mentioned that we're going to look at how we pull data from our service. So this is our service, and if I do Swagger, we'll see some nicely formatted lists. It's got one API called get tasks, but of course the one that I actually want is this JSON here, which is actually the Swagger information that I can use to generate code. Now if I go to app.swagger.hub, I can go, let's go ahead and create a new API, and let's not create that one. Let's see if we can go ahead and import that. Yep, we'll overwrite the existing one. And here it's basically broken it out. It actually reformats it as YAML, but I'm not interested in that particularly. But what we are interested in the ability to actually code gen the library for, in this case, Dart. So don't go looking for Flutter, because obviously this is a language library, so it's a Dart one. Just one note, if you are going to do this, then there is a thing here where you need to specify browser client equals false, otherwise you'll get code for Dart to be run in the browser. So there's a version of Angular called Angular Dart that uses Dart for the browser. So when you do code gen, make sure you do that, and you'll notice that you can then go ahead and generate the Dart library from there. If I go ahead and do that, it's actually going to generate a zip file, and then I'm going to need to uncompress it. I've already done that step here, so I'm just going to show you the code over here. Under to do. This is from down here down to here. This is all the generated Swagger code, and you can drill in and take a look at how it generates you a nice wrapper client library for it, and generates the corresponding models that map to the API, etc. So realistically, in my code, all I end up needing to do is go, okay, this is our API client. I'm going to then call the get method, and it's going to give me a list of tasks from the server that I can then run in my code. I think we're almost there. So what did I miss? Okay, so now we're hitting an endpoint. It's pretty unsecure. Didn't really challenge me when I hit it. So let's go and add a little bit of security to that. So to do that, I go back into Azure. I'm going to go down to my authentication block, and I've already pre-configured this with the information from Azure B2C, which I've gone ahead and set up. All I need to do here is basically say, hey, if the user isn't authenticated, i.e. they haven't presented me with a token, what do you want me to do? Now, right now it's set to anonymous requests, so let me change that to login with Azure Active Directory. Hit save on there, and I'll come back over here and go API/tasks. And so what we should see now, give it a second to roll through, is that you'll see that it's actually a redirect to log into Microsoft. It'll actually prompt me to sign in. So let me just show you that in code. So again, there's a third-party library that allows me to do auth. In this case, you pass it in a bunch of information about the Azure B2C. So there's things like client ID, redirect URI, the discovery URL. So basically, you provided that static information about which service you want to authenticate with, and then in your code, when you're initializing, all we do is essentially call authorize and exchange code. And so that one line of code, it's basically going to open a web view, get the user to sign in, and it'll actually return an auth code that we can then use within our application. So this is where the demo gods really kick in. Let's see whether this is actually going to work. Yeah. So how? It depends on what the policies are that you set up in Azure B2C. And so actually what you get back is you can get back both an access token and a refresh token. And so obviously the access token fairly short-lived. We typically keep it down to a matter of a couple of hours. The refresh token, typically you run for 90 days. And the expectation is that it re-authenticates. And that way you can revoke it and things like that as well. So, of course, demo gods. It's still running. Now, I guess one of the things that there is a bit of an offset here between the sort of the hot reload that we saw when Pooja was going through the various steps of code and the initial run. Okay, so we can't unfortunately get away from some of the build tools that are there for Android and iOS. So sometimes when you have to do a restart, and there are some things where you do need to do that. So for example, if you're referencing and bringing in a new package, or in some cases where you're adjusting some of the base elements of your app, you may well need to do an actual restart. Okay, so that did actually run. Let me just move that out of the way and bring up my... Okay, so what you didn't see is that there is no intro screen on this. So of course, it's on startup, it's going to boot me to the sign-in screen. So let me just do that. And no, even if you're watching really quickly, this is not my real username and password. Okay, and of course I didn't take any of Pooja's suggestions around styling my user interface, but those are the 5 tasks that are actually coming back from the service there. So Yeah, that's pretty much it in terms of connecting it to Azure. I mean, those are the main pieces that we typically need to do in an app. From an app perspective, what you obviously then want to do is think about caching it and using things like local database or local file store so that you don't have to keep polling it every time you run the application. The nice thing is that there are already, even though Flutter is relatively new, there are already libraries out there that allow you to do that. So whether it be something where you want to store a secure string, you can use shared preferences for that. If you want to store files, like JSON serialized files, etc., you can do that quite easily. There is also a wrapper for things like SQLite as well. So there's a lot of stuff there for a fairly new platform. It's fairly well structured out. So, yeah.
So now that we are at the end of the application, I just wanted to ask, was there something different about our slides? Where are our slides?
Yeah, hang on. They're still there.
Yeah. So. Was there something different about our slides? Do you see something that's weird about it or not normal? No? So what you see is that, as we said, that the Flutter not only runs on Android and iOS, but it also runs on web and desktop, and you see that is actually a Flutter application that I'm controlling with my phone. So that's all a Flutter application running from the same project that's running in my phone and the web. And trust me on this, I'm not kidding. We actually finished the project just like an hour back. So we wanted to like, how can we make the audience blow their minds? So like, okay, let's just get rid of all the slides and Microsoft PowerPoints and all that. And this is exactly Flutter Web for slides. So yeah.
And of course, it wouldn't be complete without an Azure connection. Okay, so it actually runs a service sitting in the background. Unfortunately, because Flutter Web is still in sort of incubation phase, there are certain dependencies that don't work. So for example, some of the I/O space isn't there, so I couldn't use things like SignalR, which would have been perfect for this. So it is a bit of a polling mechanism right now, but those things will go away as the framework matures. So the first sort of version of this, that we thought of, iOS, Android, easy. SignalR, there's already a component there for it. Like the example is just ridiculously simple to follow. But unfortunately, the dependencies are that I had some libraries there that aren't there for Flutter for Web right now. And so those are things that will come to market. I mean, it's good to see that it's in the master channel already, which basically means that they're, sort of next wave we anticipate them being released. So. Anyway, I hope you've all learned something. That's it from us. Feel free to hang around, ask questions. I think we're a little bit early, so yeah, shoot away. Yeah.
With the Flutter, how do you find working with like the camera or
So there is something called platform channels. As you see, there is do you have the VS Code? Okay.
Yep.
So here, you find something like the Android project is already there and the iOS project is already there. So there you can actually communicate with the Android and iOS projects to use a native implementation. You can write your Java or Kotlin or Swift or Objective-C code right there. Though for cameras and Bluetooth, there's already plugins already where you can go to pub.dev, where you already have all the libraries, plugins, and packages already done for it. But in case you do not have something already in the market, you can always have the communication done right in your project with the platform channels. So yeah.
So when you have to like put storage in, you have to do it separately for Android and for iOS?
So for storage, again, I guess there is already a plugin for it where you will have to do the storage. The native implementation is different for Android and iOS because they work differently, simple as that. So even if we had to add a web plugin to it, the implementation would be different. So you will have to write 3 of those code, and then all the results are back to dot files where you can just like, it's like a normal method call where you're like, okay, get storage directory.
But most of that stuff for things like storage is already there. There are already really good libraries
So mostly Google has already done all that work for you, but then there are also great Flutter communities who have built a lot of the work for you. But again, if you still need something, yes, you will have to do the separate implementation for plugins for any native communication. But for packages, which is just Dart libraries, then obviously you don't even have to touch your Android, iOS, or web folders.
So today we use Swagger, but I mean there is also implementations of things like Retrofit. So there's a package called Chopper, which I'm not sure where the name came from, but that's basically a Dart version of Retrofit. So be used to that sort of behavior. Yep.
Do you need a MacBook to sign your iOS app?
Yes, you do.
Yeah.
There's no escaping that pain,
Though
unfortunately.
I think CodeMagic has a solution there.
Yeah, so
Yeah.
if you don't mind building in the web, yeah, you can definitely do that. So
CodeMagic is like a CI/CD tool for Flutter, and recently only they actually found released a feature where you can sign your apps without a MacBook.
Yeah.
So yeah, that's great.
Not yet. So the bolt into Azure DevOps is very much a third-party extension for it. So in theory, you could do. I know that Adam Pedley, who used to be like a Xamarin Forms blogger, was actually blogging about using App Center to do build and release. So he's actually got quite a comprehensive guide as to how to set up App Center to do that build and release pipeline, because it is a bit of a pain for everyone. Yeah, well. Yeah, so even in Azure DevOps, you don't need to do that because one of the build agents is actually a Mac, so you can actually get it done on there. So that, in order to sign things, the Mac is still the requirement, but there are cloud providers that allow you to do that. So yeah, I mean, if you want, you can generate the build and sign it and stuff like that, just using the Mac build agent in Azure DevOps. So I guess one thing we kind of loosely touched on it, is that one of the big differences that is the rendering here, we didn't mention, is actually based on Skia. So, unlike other platforms that use the native controls, basically the approach that Google has taken with this is just give me a blank canvas. I'm not interested in these native controls that don't perform well and that we all hate anyhow. Just give me a blank canvas and I'm going to draw everything. So they actually use a native implementation of Skia to actually render everything on the screen. So everything you see, within the apps is actually rendered by Flutter essentially. So, yep.
Do you find much, like you're developing a Windows with an Android emulator?
Yep.
Do you find much difference between iOS, like how they render the app that performs and develops between the two?
So in terms of rendering, there's not a significant difference. The base of your app, you pick either a Material app or a Cupertino app, and that basically defines the look and feel. There are some device peculiarities. So for example, on the list view, when you hit the bottom on Android, you'll get like a sort of oval shape to indicate, the sort of the splash that indicates here at the end. And then on iOS, you kind of get that bounce feel. It's completely controllable. You can turn those things off if you don't want them, if you want a very standard look and feel for your app. But they have done some tweaks to make it more acceptable, because they recognize that, one of the reasons why you want to do Flutter is so that you have the same uniform experience. So there's no point in going, hey, I'm going to do this big if then else at the top of my thing and go, hey, here's a Material app and hey, here's a Cupertino app, because you'd end up having to build everything. You could reuse logic and stuff like that, but you may as well pick a different framework if you're going to do that. But no, I think in terms of just the build and release cycle or the dev cycle, there's not really much difference. So long as you get it up and running. Now, obviously, I'm on a Windows machine, so they don't have the equivalent of the remote simulator that you have in the Xamarin world. So if you're going to do Flutter development for iOS, you basically need to do it on a Mac. So, yeah.
So what do you actually compile to?
So it's actually compiling to native. Yeah, it's actually compiling to native. Yeah, so. Yeah.
And so if you look at the iOS and the Android code, so the Java code, literally there's a main activity that loads your Flutter blob, and that's the entrance point. Now you can do other stuff there if you want in the sort of the Java code. And actually you were saying that some of the apps that you're working on is actually an Android app that actually then loads,
so some of the
Flutter.
applications that I'm working on is like existing Android and iOS application where we are inputting Flutter into it. So it's actually building from an Android as an Android app, but then the screens and the interaction and everything is actually a Flutter block or something. So like we have few screens on Android native and we have few screens on Flutter itself. So even if you do not want to actually build your application from scratch in Flutter because your company or your product you have already invested your time in it, so you can always do the new features in Flutter by inputting Flutter into it instead of going to the Flutter path. So yeah.
So it's not so much support for SignalR, and this is just for the web, the Flutter for web. So again, the support for SignalR is actually just because a third-party developer has created a plugin for it, and so they've got the relevant bits for iOS and Android there. And actually, I don't think it's got any dependencies on the specifics of iOS and Android. But it does depend on the Dart.io library, and that's one library where the web is currently different from iOS and Android. I think it's just an implementation detail that they're trying to iron out, basically. So, yeah.
That package that you pulled in, was that like an official package, or did this like a third party?
No, so that one's actually, so one of the guys who used to work at Built to Rome actually created that one. So I think it's called Flutter Auth. But there are a number of different ones out there. I don't know that any of them are official as such. I think maybe the Google sign-in one might be because it's produced by Google.
Yeah.
But the rest of them are done by third-party developers. One of the bigger ones, James Clancy's done one that basically caters for nearly all of the different auths you can possibly think of. So that's quite a popular one as well. So, yeah.
With the Azure App Service, is the Swagger stuff built in?
Sorry, say again?
With the Swagger, with the Azure App Service, you've got the Swagger definition and the Swagger UI.
No, it's not built in. I imported the Swashbuckle library and used that. This is the service that's there is actually a .NET Core 2.2 service because the Swagger support for .NET Core 3 isn't quite there yet. It's still in release candidate. And the code generation doesn't, even for .NET, doesn't actually work on it right now from Swagger Hub. So we found that in a new project. Yeah.
So I noticed that when you were going through the demo, all of your UI is defined in code.
That is correct.
Yes.
So there's no third-party extraction or abstraction away from it. So yeah, it's a mixed blessing, to be honest, because one of the problems that you'll then have is mixing business logic with code with the layout, and potentially some quite large layout trees. And then you run into issues. Okay, well, I don't want the whole page to be or the whole widget tree to be rebuilt every time. So state management becomes a bit of a challenge in passing that around. So it's definitely something that can be something that you need to come to an agreement with your team as to how you're going to handle that and where you're going to put that kind of logic, and how you're going to factor out classes and widgets and things like that. I mean, most people are used to a fairly common philosophy of having a class per file. And what you'll find quite quickly in the the widget world is, as you start to break out your UI to make it more digestible and easier to follow, you'll end up with a single page might be broken down into 5 or 10 widgets, but you won't necessarily want to put those into separate files because otherwise you'll end up with like thousands and thousands of files, and chances are that those widgets might only ever be used on that one page, and you've just moved them out so that it's easy to work through them. And so you end up in the scenario, I mean, even things like the widget and the state, you typically keep those in the same file. So that kind of mentality of moving things into separate files, again, you just got to come to an agreement with your team as to how you're going to do that.
It's just good programming, I think.
Yeah.
You just have to find a good architecture to actually separate out your UI and your logic, and yeah, that's it. Initially, whatever examples you'll find, everything will be actually on the same page, but then again, it's just your choice of actually having good programming right there and good architecture skills that you should just divide everything there. It is possible, of course.
Yeah.
Being from Microsoft background, how did you find adapting to Dart versus C#?
So Dart was definitely not a problem. I mean, I still find that sometimes I get the syntax wrong because I'm used to the C# equivalent, but I do definitely particularly because it is UI in code, there's some niceties in Dart that you don't have in C# that make it more suitable for doing UI in code. So that cascading operator I was talking about means that you can essentially declare an object, you know, dot dot this, dot dot that, dot dot this, and you can apply them directly to those objects as part of that single statement. And because the build routine, it's got one line of code basically, so you need to be able to do that type of thing. And it's got some other things like spreads and I'm sure there's some the way it does optional parameters is quite nice. Yeah, there's a few nice things to it. Yeah. Sorry? It does private variables and private methods. Yeah. So there's no namespacing. You can have global variables and methods. So you run into the whole web issue of things colliding, but you can do aliasing within files and stuff like that. So it's got some very clever things around compiler optimization. So you can have constant constructors of classes. So essentially, if you call the same constructor with the same parameters multiple times, if it's a constant constructor, it'll give you exactly the same object back. So there's some optimizations there. It's got a notion of final variables, so you can assign things to a variable once, and then if you try and reassign it, it complains. There's a lot of kind of nice things to it, but the answer is no. I didn't find much issues coming to it. Occasionally, I forget the syntax, but it's easy to look up. Yep.
Question to either of you: can you think of or name something you consider a killer feature compared to other cross-platform?
The first thing that comes to our mind would be the hot reloading part, was that it's that quick update thing, and it's not just for UI, but it's also for logic. So it's not like you are probably like you were talking about one of the frameworks where you can just like update the UI really fast, but then here even the logic will be also updated. So like you just like change your entire API call and then it will still just update it right away. That was one killer feature for me because I was coming from native where we had to like build like for like 5 minutes just to get things done. So that was really quick there. Other than that, I think the widget concept was really, it was difficult at first, but it was really easy later on to have custom UIs, because now that everything, what you give is a widget, what you return is a widget, that means you can do anything with that particular widget. Like you can actually build crazy designs and crazy work with that, and that totally was like it eased our development work a lot, because we can now do all this, whatever the crazy designs our designers throw at us, we can build that very fast, and logic in itself was not a big deal. Since I was already having a native experience, I was not having a problem of doing platform channels. But yeah, people who are coming from not a native channel, not a native background will have a difficulty there, because if there are something plugins are not available, they will have to write it. That's one problem that non-native people will have, but I did not have that, so yeah.
Yeah, the UI side of things, for me, it's less about the way that the widgets work in terms of the build cycle and things like that. It's the fact that, you know, if a designer comes to you with a design, I would probably say it's probably a third of the time to implement it in Flutter, but I'm just finger in the air type estimates, but it's significantly easier than thinking, okay, well, I've got a text field on the screen, how the hell am I going to get rid of the hard borders on it and make it look really good?
Yeah.
I mean, look, in the Xamarin world, they've done a lot of niceties around trying to make it easier, so they've got like a material look and feel to it. But then if you contrast that to the widget gallery that's available already for Flutter, like the simple examples of, you know, using a card or using there's so many of the built-in sort of the material design elements are already there as dedicated widgets. Now, some of them are actually just repackages version of other widgets, like in the sense of the card. If you look at the way it's broken out, it's basically just a box with a bit of text in it. But they've got some nice things around the way that the edging's done. They've done a whole bunch of stuff around the semantics of it so that you've got accessibility for it, et cetera, like that. So those things that come out of the box is one of the things I think that actually sets it apart. And, you know, they are light years ahead of where other platforms are, you know, whether it's, you know, React Native, Xamarin Forms. To a degree, even UWP. I mean, UWP is super powerful, and you can customize to the nth degree all the elements. But, you know, in order to build a nice looking app, you really have to work hard. Whereas, you know, the widget gallery and all of the options that are available on all the different widgets just make it really easy. So for me, that's where the benefit lies. Hot reload, sure, okay, it probably has a better version than Xamarin Forms currently does right now. Look, I come from a Windows background. We've had edit and continue for like the last decade. So hot reload, okay, it's rebadged, but so what? I've had like my Xbox app that I keep on working on, I've had edit and continue for like since I started building it 3 years ago. And it's sort of like, well, okay, so I don't get off on that so much, but just the availability of all of these different widgets and the ability to customize them really easily just takes a lot of the burden away from building apps. So. Sorry, one more? Yeah.
I just wanted to ask quickly that dependency injection, do you do that in Flutter?
Yeah, we have.
Also unit testing?
Yes, unit testing also since we have our widgets actually built on Flutter, so the unit testing libraries are pretty great there. That we have unit testing, we have widget testing, we also have normal integration testing, and then dependency injection. There are like few options there. One would be the Get It package. It was actually built by a community person in our Flutter community, and it's been heavily used by projects. But other than that, if you want compile time dependency injection, there is something by Google called @inject. That's like there are like multiple options. So you just have to like know what your project needs it. So even for like there are a lot of things, and you have multiple options for each of them. So you have to like sit with your team and actually decide what you want to do or why you want to choose one option. So yeah, there are multiple options there. Yeah.
You tend to find that stuff exists sort of outside, a little bit outside the widget world, in the sense of, you know, if you're building like service classes and things like that, you'd quite often use dependency injection to pull those together. For your widgets, typically they don't, because you're typically passing them static values because of the way the build cycle works. So you typically won't be injecting things into widgets, but maybe into the state you might have dependency injection. But more, it's the sort of the architecture there is more service locator than it is actually dependency injection. But it kind of, they're not too dissimilar. So, yeah.
All right. Thank you so much.
Thanks very much.
Thank you.